So this final example for my December 2013 programmable logic in practice is interfacing to a DDR chip on, again, the LX9 microboard I'm using. And again, this is really cool because there's pretty minimal. So Xilinx gives you a memory interface generator, which will give you this IP core. And there's just this tiny wrapper around it. So this is the MIG, this is the core that Xilinx gives you. And I just want to test it out, and I'm not interested in making this like the final interface in my system. Maybe I want to check out the board, or just check how things are working, or test my higher layer code is working with the physical device. So there's a number of real I/O pins, and again, you have to remember I have the same system where the top layer simulation process properties, I've set up the hardware constraints. And that's the UCF file that maps all these to the physical design. So I have a system clock, different than the clock the hardware COSIM block is using, as well as all the DRAM locations. And then the upper layer ports are just basically the entire control ports for the Xilinx block. At the higher layer, we have a test bench that interfaces to that Xilinx block. And this test bench is pretty basic. It's basically modified from a Xilinx app note, but the point is that it's showing you, this is really simple stuff we're doing here. We're not pushing this to the bounds. We're just using this to get up really quickly. You can do this in a few hours or maybe a day. Anyway, so if we hit simulate behavioral model as normal, it's going to do this standard thing where it goes through, synthesizes the design, as required, and then launches the simulation. So again, we have the LX9 microboard. So it's this guy once again, and I'm just using the built-in USB to JTAG adapter. So there's this, there's a low-powered DDR chip on this board. I believe that's it anyway. And it's connected to the Spartan 6, LX9, very small Spartan 6 device. So you could use this type of thing for any real high-speed serial interface that you want to test. For example, PCI Express. This would be really handy to use with. Here I'm using DDR. If you have USB interfaces, the whole sort of that type of thing. And again, if you get errors here, you can see all it's saying is implementing. It may help to switch over to the implementation tab, and you can just implement the design as if you're going to implement it. In a physical device, it may have issues because there's so many ports connected through the test bench. Like you can see all of these large ports are going through the test bench. So it may cough out at some point because it doesn't have enough I/O pins, but often even just running the synthesis will give you an idea what the actual errors are. So I find that a little easier to just pop into this side and run any process you need rather than finding the actual log files that it's written somewhere when it's implementing for the simulation phase. So again, I'm more or less just talking while I wait for the hardware COSIM stuff to finish implementing within the Xilinx software. As before, we have the hardware COSIM. We have to figure out what the clock port is that the system is going to generate. And if you want, you can enable that incremental compile option. And once it's finished, it's going to run. So downloading bitstream. And that's actually, it's system reset done. So it's tested the memory cal, read write, so it's actually paused after 1 microsecond here, so we just tell it to keep running. And it just goes through the memory test. So this is really cool because now you're verifying your hardware is working using the Xilinx block. And it's saying no data mismatches found, read write test done. And if you want, you can restart it. And I'll see if I can do this here. If I put my fingers all over the data lines, it may or may not be able to introduce data errors. No, you can't. But you can see that if you do physically change the board, you can watch the errors come up here. So that's how we test the DDR block using the hardware COSIM on these Xilinx tools.